Hi everyone, Tina here, and today I'd like to talk about implicit differentiation. You'll usually come across this topic during year 2 of your A-level course. I have made other videos on differentiation, so I'd recommend you watch those ones as well. You use implicit differentiation when you want to differentiate equations that involve functions of both x and y. I'll show you how it works through a couple of examples. Example 1. A curve has the equation 2x squared minus 3xy plus y squared equals 12. Part A, find an expression for dy dx. So for implicit differentiation, you differentiate as normal, but when you differentiate y, you times by dy dx. So for part A, if we do this, the first term differentiates to just 4x normally. And then for that second term, minus 3xy, we want to do a product rule to differentiate that. So I'd probably do that over to the side. U equals minus 3x, v equals y. du dx is minus 3, and dv dx is 1 times by dy dx because we're differentiating y. Product rule then says that it's v du dx plus u dv dx. Sub everything in and you get minus 3y minus 3x dy dx. This is the result that you then want to substitute into your main differentiation work. So that's minus 3y minus 3x dy dx. Carrying on differentiating then, to differentiate y squared, that's going to be 2y dy dx, because we multiply by dy dx whenever we differentiate y, equals 0 because 12 differentiates to 0. Now we have this equation, all we need to do is rearrange for dy dx. To do that, I usually group together anything that's got dy dx on the left-hand side and move anything else over to the right-hand side. You can then factorize dy dx out, and then you can divide through by minus 3x plus 2y to get your answer. And that's it for part A. Part B, find an equation for the normal to the curve at the point 1 minus 2. From part A, we know that dy dx is equal to 3y minus 4x over minus 3x plus 2y. All we need to do is substitute in the x and y coordinate. So at 1 minus 2, dy dx is going to be equal to 3 times minus 2 minus 4 times 1 over minus 3 times 1 plus 2 times minus 2. That gives you 10 over 7. And that would be the gradient of the curve or the tangent at that point. That means that the gradient of the normal will be the negative reciprocal. That would be minus 7 over 10. We take that gradient and we substitute it into y equals mx plus c or something similar. And we get this. Means c is negative 13 over 10. So your full equation of the normal is y equals minus 7 over 10x minus 13 over 10. And that's it. Example 2. A curve has the equation 2 sine x plus 2 cos y equals 3. X is between 0 and pi, and so is y. Part A, find an expression for dy dx. So if we jump straight into differentiating this, 2 sine x would differentiate to 2 cos x, and then 2 cos y would differentiate to be minus 2 sine y. And then because this is implicit differentiation and we're differentiating y, we have to times that term by dy dx. Differentiating 3 gives us 0 on that side. We then just rearrange to make dy dx the subject. When you do that, you get this. 2's cancel, you're just left with cos x over sine y. And that's it. Part B, find the coordinates of the point where dy dx equals 0. Let's set our expression for dy dx equal to 0 in the first instance, and then solve. So for this to be true, that means that cos x has to be 0. There's no other way that cos x divided by sine y would be equal to 0. Therefore, x would be inverse cos of 0, which is pi over 2. Always worth drawing a little sketch whenever you're solving a trig equation. So if we sketch cos, 1 minus 1, 0, there's pi over 2. So that's the first positive angle where cos x equals 0. Here's pi, 3 pi over 2, and 2 pi. At the beginning of the question, they specified that x had to be between 0 and pi. So our answer of pi over 2 is good. Now we need to find the y coordinate. So when x is pi over 2, if we sub that into the original equation, that would be 2 sine pi over 2 plus 2 cos y equals 3. And that is coming from substituting into this equation. Solving for y, cos y would be equal to a half, means y is inverse cos of a half, which is pi over 3. And that fits the specification for y being between 0 and pi, so that's good as well. Therefore, final answer for coordinates, pi over 2, pi over 3. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.